Welcome to Gridlock, Engineering for the Real World. I'm Dr. Paul Moses, an electrical engineer, educator, and researcher based in Oklahoma. Every time you switch on a light, charge an electric vehicle, or use an appliance, we're relying on an incredibly complex system that most people never think about. Behind every reliable source of electricity are difficult engineering decisions, economic realities, technological innovation, and public policy, all balancing competing priorities. This podcast is about those real-world trade-offs. In each episode, I'll be joined by leading experts from across engineering, energy, government, industry, and academia to discuss the challenges shaping our energy future. We'll explore topics such as grid reliability and resilience, affordability, infrastructure modernization, renewable energy integration, nuclear power, cybersecurity, and many other technologies that will define tomorrow's electric grid. Our conversations begin here in Oklahoma, but we'll also examine national policy, international developments, and the global engineering challenges facing modern power systems. Whether you're an engineer, student, utility professional, policymaker, researcher, or someone just curious about how our world is powered, this podcast is designed to bring thoughtful, evidence-based conversations to the forefront. We'll move beyond headlines and explore what really works, what doesn't, and why engineering decisions matter. Thank you for joining me as we explore technologies, ideas, and people building the future of energy. I'm Dr. Paul Moses, and this is Gridlock, Engineering for the Real World. Hi, I'm Paul Moses, and today I just thought I'd chat about some thoughts I had in my mind about electrical usage. I remember growing up in the UK in the 80s and early 90s, and my parents, we lived in a flat, they called it there, an apartment, and the electricity meter was inside the house near the front door, and the meter man would come inside the house and take a reading once a month or so. But I remember with spare change that you can actually feed the meter. It was quite common there, where you would just put coins in there and you'd have power for a day, maybe two, with just spare change. And of course, then our expected consumption there was very little. I mean, we had fridge and fans and kitchen appliances, but not much, not like we have these days. But that was how it was then. And then growing up in Australia in the 90s, I remember we didn't have a clothes dryer for a long time, not until the 2000s. We just hung our clothes out to dry, and we saved quite a lot by doing that, and that's still also quite common there. And then air conditioning became a thing, reverse cycle or refrigerant air conditioning, and that caused a huge surge in our grid, and in the 2000s, particularly in Australia, and the utilities were struggling to keep up, and they had many outages and fuel shortages because of those kinds of paradigm shifts. And then in America, I think our consumption here is quite a lot higher per household than most other countries. We have just a lot of gear in our house now, and now with electric vehicles and more appliances that we've come accustomed to, our expectations have grown, our standard of living has improved, of course. But this has had repercussions on the infrastructure. The infrastructure is still an legacy architecture. It served us well, I would hasten to add, from the late 1800s. Those decisions they made back then, they could not have imagined how we're using the system right now with all the consumption we're having, and now distributed generation and solar on our houses and so on. And yet we're using that same infrastructure. It's really quite remarkable. Nonetheless, I think we are seeing, since the last 2 decades, our consumption at the residential level has been pretty moderate, like 0.5% to 1% growth per annum, fairly stagnant over the last 2 decades until the 2020s. We've seen an uptick in the load growth, and not just residential, but industrial as well, with electric vehicles and charging stations. And now data centers is the next big thing, and who knows what will happen a decade from now, what the next big thing is. So utilities are forced. It's not that they've not planned in advance for this. It's they have when they install power lines and transformers and switchgear, they do anticipate a certain load growth based on historical patterns. But what we are seeing now is breaking those trends by orders of magnitude. I think research has said that in this country, by the year 2050, our transmission infrastructure has to double in capacity at least to meet new demands from data centers and industry consumption and population growth and so on, which is quite a staggering proposition because it still takes a decade or two to plan out and get permission to put in new transmission lines. And then, when we drive past these transmission lines, is there any way to get rid of them and put them underground or get them out of sight, rather than having more lines crisscrossing our state? And these are all engineering challenges that we're going to be discussing with future guests. Particularly, I'm interested in the disparity that we're seeing in different infrastructure at the distribution level in a city. Older versus newer neighborhoods, for example. If you live in an older part of the city, your power lines entering the house are above ground and more prone to weather damage. In fact, we just had a big storm here 2 weeks ago, and a lot of trees were blown onto lines, and the lines themselves were knocked down. And we're still seeing a lot of cleanup being done around the neighborhood to collect those trees. The rural areas were more affected as well in Norman City outer skirts. But the newer neighborhoods that have underground, they have a little bit easier restoration. But this points out a disparity in and how we feel about this. If we have two neighborhoods served by the same utility, same substation, one is older, one is newer, they will have inherently different reliabilities and different restoration times. If you live further out from the substation and your power is knocked out, usually it takes longer for your power to get restored. And because the repair people usually work from the substation, repairing the line outwards away. So do we consider these things when we buy a house or choose where to rent and live? That we probably not. We're more focused on the quality of the house. But there is an inherent reliability difference and restoration and resilience. And we'll talk about those definitions later on, depending on where you live. And how, as a society, should we reconcile this if in a particular zone, our neighbors are paying the same rate? One is going to have an inherently weaker system and the other stronger. And not only that, in the US and worldwide, there's many nations have a patchwork of utilities. Some are for-profit, some are not-for-profit, some are government-owned, investor-owned. They all have their different rate structures. And therefore the customer, again, sees some disparity in the quality of service for comparable households in different parts of the city, different parts of the country. So moving forward, these raise very important questions. If we are going to embark on a modernization of our grid, which is being talked about at length at many countries, not only do we need to modernize our technology, do we still use this century-old architecture, which has served us well, keep doing the same with modifications here and there to accommodate these new renewables and electric vehicles and so on? Or do we fundamentally change it to something radically different, which is being really talked about in a lot of countries and this country? Should we move away from AC and go to some sort of hybrid AC-DC system and have less reliance on transmission and more distributed generation? I think those are important questions to have at this time, but I think we should also remember that we have a duty to make sure that we don't fall back into electricity becoming a premium like it was when it first came out in the late 1800s. Only the very affluent could afford it. And then I see we're sort of returning to those kind of things where the cost of energy is just escalating a lot. So we need to have these deeper discussions and community involvement, which traditionally with infrastructure planning have always been a top-down approach with very little community say so. Does the community know this is how much it's going to cost, and why are we paying these grid modernization charges, and what do we get? What's the value we get as a community? So we will have these discussions with future guests coming up. In conclusion, I just want to thank you for your attention, and hopefully we can have a more open discussion about the future of our grid and what trajectory we should go on to make it a more equitable system for everyone, and not a patchwork of different expectations, different services to different groups. Thank you very much.